2?
Yeah, I was really confused on how to do it.
Let me unconfuzzle you then.
I feel like I did number 1 right.
I hope you did, because I did it with everybody.
Oh yeah. Wait, I was gone. Oh yeah.
Touche.
Wait, you did that question with everybody?
Oh yeah. All right, so question 2 says,
What did we go wait?
write the equation of the parabola whose focus, the focus is at 0, -2, and the directrix is at y equals 2. So here is my directrix, and here is my focus. Now, just by looking at that setup, I should know that this parabola is going to be a negative parabola, correct? Good morning, sir. Happy Friday. I should know that this parabola is an upside down parabola, correct? Okay. Now, where should my vertex be? It should be right at 0, 0, because it's equidistant from the 2. So if I count the spaces between there, there's 4, right? So my vertex should be right at 0, 0, which is nice because in the formula, I don't have to worry about translating x or y, do I? That's beautiful. I like it a lot. Okay, so here's what I know. Because this is a vertical parabola, it's going to take on the form of x squared equals 4py. Correct? Has to take on that form. Now, p is simply the distance from my vertex to my focus. And how did I have to travel to get there? I had to go down 1, 2 units, didn't I? Therefore, p is a -2. Go ahead.
So it's always from the vertex to the focus?
Correct. Yeah, and I do mention that it's the same distance to the directrix,
Yeah,
but it's correct. It would be the opposite direction. But yeah, p is definitely from vertex to focus. That way we get the whole signs correct. So all I have to do now is plug in my p value, well, my value of p. I'm,
Wait, but why is it 4?
that's part of the equation. Oh,
That's how everything is. It always has to be.
we will prove that today.
Oh, wow.
We're proving that today. Remember I told you, just trust me on this for now?
Yeah.
Let's work with it, understand it, and then we'll prove it. And we'll prove that today. Yeah?
So no matter what, we have to use that equation?
Yeah, that's the equation. You know how you always used y equals mx plus b?
Yeah.
This is equivalent for a parabola.
Okay.
All right? Does that make sense? Does that click a little bit more? Good. So now I just need to finish up my parabola. I know that -2 is the p, and I've got y, so that means that x squared equals -8y, and there's my equation, friends. For sure. It's also on the board over there behind everybody.
Yeah.
Or in front of you. Or in front of you. And then there's another one over there. Yeah. Yeah, there's Juan and there's two. Any questions on this one?
No.
Please ask. I know it looks easy right now, but ask yourself, does every step make sense to you? Because remember, math is not a spectator sport. You can watch me and be like, oh, that's so easy. But then you go home and you're like ripping your hair out in chunks.
You got -2 because of the coordinate of the...
Because of the distance from this vertex over to this focus. And that's where it comes from. Yeah? Well, think about this. The points that I start to create have to be equidistant, right? And since I have my vertex and that's right below it, that's going to have to take on the shape kind of like this. So it's a vertical parabola. Yeah, if it was a horizontal parabola, well, I don't want that. I like page width. If this was going to be a horizontal parabola, then I would have a vertical directrix. If it's That's a fantastic way of thinking about it. If my directrix is horizontal, then my parabola is vertical. If my directrix is vertical, then my parabola is horizontal. And then I'm just going to face my focus. I have to face my focus. Face your focus. Ah, that's a cool shirt right there. You like face your fears? Face your focus.
Math is my favorite.
Don't be afraid of math. Math is fun.
It's
all
fun,
about patterns. It's just patterns.
What if someone did a big total of everything that's in math?
It's
Is
I don't know
that actually is that a real thing or
So how many parabolas are there?
One.
One. There's only one parabola.
Yeah, but
And what do we do with the parabola? Here, let me do my Michael Jackson dance. All we can do is
there's that.
and make it bigger. All you can do is translate it and dilate it. It's only one parabola.
It's kind of like a circle.
Much like a circle. All you can do is translate it and dilate it.
Wait, didn't you show like your other class? There's only one.
Oh, do you guys want to see that? We haven't shown you that, have we?
No, I want to see it. Told me about it, so I watched it.
Did you? You guys want to see it?
Yeah.
Matt Parker? They were all confused, so I chose not to do it again. Because they were at the end, they're like, I didn't make any sense. Did it make sense to you?
Kind of.
It's just the math behind it. I think I proved it a little bit easier than what they did. But anyways, moving on.
Do yours and then you're watching it.
Let's finish the questions on the homework. We did 2. How about 3?
I need to help 3, but if no one else does, it's fine.
3? Okay. And I hope you guys are writing this down.
Yeah.
I like homework to be hundreds. Hundreds. Okay. Looking at this parabola, I can already see that the x value is a squared one. So what type of parabola am I working with? It's a vertical. And because, do you see the negative in the front? That means it's going to be upside down. Okay? Now, here's what I'm going to do. First thing I'm going to do is I'm going to, let's see here. Y minus 3 is equal to negative x plus 2 squared. Now, since I'm going to make this easy on me, that minus 3, everyone understand that y minus 3 is simply a number, correct? Because of closure, the closure property. So I'm going to just keep those together because it really clears things up for me. I don't want this x to be negative. I'm going to go ahead and kick that to the other side. So I can just change signs, can't I? Correct?
You can still do that.
Yeah. Whatever I do to one side, I do to the other side. So if I change this sign, then I got to change this side.
Well, why would you want x to be positive and y negative?
Because now that it's positive, I know it takes on the form of y equals 4 py. See how x is always positive here? Or the x squared is? So now what I can do is I can just do, all I'm doing is some algebraic manipulation. So let me rewrite this equation in this form. And it would read x plus 2 squared equals negative something y minus 3.
But where's p for?
Fantastic question. That's what I need to answer in order for me to be able to find the focus and directrix of the parabola. So, here's what I know. I know that 2 and negative 3 are simply translations, aren't they? Right? That means that my vertex is at negative 2, comma 3. There is my vertex right here. I'm going to label it with a little v. Correct? Now I just need to ask myself, how did 4p become a negative 1? Exactly, negative 1/4. So that means that p was a negative quarter. Therefore, this is going to be a vertical parabola, so it's negative. P is negative, so it's going to do this, isn't it? Which means that my vertex is simply, what value is this? 3. And this is, what, negative 2? So my focus, I'll write it here. My focus will be at negative 2, comma, let's see, 3, but it's down a quarter, isn't it? So it'll be 2 and 3/4?
Where'd you get the 1 from? Like, why?
Yeah, I don't get that.
You just like put it there and I was like, what?
Because of the identity property. Identity. How much is that? Can I write that as 1 times 4?
Yeah.
Where'd that 1 come from? It's just part of identity.
Okay.
But it helps me realize what the value of p is. Because negative 1 times this is still just that, isn't it?
How was P negative 4?
Well, how does 4p become negative 1? And I can write an equation for that. Everybody just kind of spit the answer out. But the way I would have done it algebraically is, how is it that 4p equals a negative 1?
Okay, so you're just dividing.
Huh?
You're just dividing.
And then I would divide by 4 to both sides, which means that p would have to equal negative 1/4. Math! Like 3 people jumped. Isn't that beautiful? All right, cool. So, now the directrix, right? Tell me something. Where's the directrix? Isn't it equidistant from the focus? So that means I got to go up another quarter unit. So I should be at y equals 3 1/4. And there's my directrix.
So what I'm confused about is how do you know if we're in the directrix? Like how do you
Well, remember, this is a negative parabola, correct? So I already know its shape is like this. Focus has to be inside of there, and the directrix is going to have to be above it. So if I had to move down 1/4 unit this way to get to my focus, then I got to go to quarter unit up to get to my directrix, because they're equidistant from the vertex. Right? Does that make sense? Hallelujah. Because where the vertex was at. So we had to go up 1, 2, 3 for the vertex. So that means I got to go quarter unit up for the directrix. Fantastic questions. So what was the band she was all supposed to like again? Some band she really likes that you were like probably suspicious.
Oh, it's 21 Pilots.
Oh, 21 Pilots, sorry.
I think that's why I was right.
Do you ever braid your string cheese? Just for fun.
When I'm really bored, I'm like,
My little girl likes to make the cheesehead guy. She'll, and then she eats him.
She eats them.
Fantastic. Any questions on number 3?
wait,
Not as bad, is it?
keep it there.
Wait, so it's the blue right there,
No.
the little blue dot, that's the focus?
That's the focus, and then the directrix will be right above.
This is just too little.
I will do one more.
Just do it.
Oh Lord.
He said it.
I'm gonna do one more, and give you the weekend to turn this in.
God bless.
Thank you.
So that
Thank you so much.
well, I mean, I'm not gonna be that guy that you don't get it, and I'm gonna move on. If you guys still need more practice, then you guys need to go back. But I want it done. What?
Our homework, if we didn't get it, like.
Yeah, if you didn't already finish it, then you'll get the weekend. And if you finish it, then guess it is.
Can we like, if we already submitted it, can we like take, submit it?
You can't unsubmit it, but go ahead and do it on paper and then bring it in on Monday. I want it done, and I want you to get your practice in. That's what it's about. No, it's participation. And because here's what the purpose of the homework is. It's not for me to give you a meaningless task. It really is for you to take and practice those skills. So if you can go through and you can do them, then great. If you can't, then we ask the questions and I answer them, and then you're like, okay, now I get it. But right now, there's a lot of people struggling with it. It's hopefully not meant to be, but I can see that there's a need, so I'm going to give you more time. Okay? So, let's see here. What's this guy saying? I never got to do one of these yet, so I'm excited. A parabola has its vertex at the origin. So a parabola has its vertex at the origin, which is 0, 0, and the focus is at 0, 4. 1, 2, 3, 4. Find the length of the segment that passes through the focus is parallel to the directrix. Well, let's see here. Directrix has to be 1, 2, 3, 4. So here's my directrix, correct? At y equals -4. Let's see, it says find the length of the segment that passes through the focus. So it has to pass through here. It's parallel to the directrix, whose endpoints lie on the parabola. Ooh.
We just need to figure out like how you find like what's on the parabola.
Yeah, so what we need to do is we need to find the distance. Oh, that's fantastic. That's fantastic. So, let's see here. Let me give you the proof, and then I'll let you try this again, okay? Because the proof has more algebra in it. that will be useful to you. And if we can't get it, then we'll do that one, okay? So, are there any other questions besides the word problems, like the easy, not, I should say the easy stuff, bad numerals. As long as it's not a word problem, because I really want you to work through those. Okay? So let's go. It's not?
It's like the thing that has that.
Oh. Which of the following parabolic equations could be used to represent the graph at the right? Well, what we need, let's see here. This is vertical, so it's going to take on the form of x squared equals 4py, correct? Now, the focus has been translated. It is at, let's see, here's 0, 0. So let's look at x first. So it'll be 1, 2, 3, 4. So that makes it x minus 4 squared equals 4py. And then the y was shifted up 1 unit, correct? So that becomes y minus 1. So let me erase that. So does everybody see how translations work? They're pretty simple, right? It's just simply like we did with circles, the opposite of type thing. Same. We're trying to figure out which of these equations fits this parabola. Okay, and yeah, they're probably different versions, huh? Because all they've done is math the heck out of it. Now, the directrix is half a unit away. So let's see here. So that's going to be a unit. Yeah, that's a half below, so that's a half above. So half of, so p is 1/2. What's half of 4? 2. So to make our equation, this simply becomes 2. So is that one up there? Can it be this one? Can it be B? No, because y is squared. This one, the y is squared again.
But it's
Can't have the y squares. Let's see here. Here it is. Here's one of them. That's our version. Do you see it? That's our version right there. All they done was use the reflexive property to write it backwards. Let's see here. To figure out the rest of them, we're just going to have to math. We'll have to expand the x squared side. So that will give me x squared minus 8x plus 16 equals 2y minus 2. So I can add 2. That would give, at 2, x squared minus 8x plus 18 equals 2y. Divide everything by 2. Correct? So I would get y equals 1/2 x minus 4 plus 9. Is that even up there? No, but this one is. Do you see this one?
Yeah.
They left y by itself. So let me. Yeah, so let me rewrite this one more time for you. X squared minus 8x plus 18 equals 2y. And what they did for a was simply move the 2y to the left side. Yeah. That one's A. This one can't possibly be the one. That's gone. E can't be. There's no other values in there. There's no shifts. There's no shifts. If you think about the 1/2 x squared, let me just show you what y equals x squared is centered at the origin, like this, right? And if I change this number up front, it just changes the slopiness of it. So by going y equals 1/2 x squared, it's just made it wider. So it hasn't translated it. Okay? There's no translation there. So let's go back. Where'd it go? Here we go. So I've got two other options. Can it be this one? Can it be D? D is very much like A, except they added 14, which was the if you made a mistake and accidentally subtracted 2 instead of adding 2. You see that? So this is if you made a mistake with your minus 2 here. The only other option is C. You guys ready to see how and I'm thinking it might be. Okay? So I'm going to take x minus 4 Okay, so let me clear this. Okay, do you guys remember that? You guys have that equation, correct?
Yeah.
So let me see if I can manipulate this. I'm going to take, I'm going to multiply this by 1/2. I'll use red. Hopefully red works. If I multiply this by 1/2 and multiply this by 1/2, this goes away, doesn't it? Correct? Isn't that just a 1? Well, it doesn't go away. It's a 1. Sorry, that's bad math right there. That means that I would have, let me point you in this direction, I would have 1/2 x minus 4 squared equals y minus 1. Correct?
Where's the one?
Well, it's from here, the y minus 1. I just wrote it without the parentheses this time because I'm going to math that one. I'm going to add 1 to this side, and if I do it here, I've got to do it over here, don't I? So that would become 0. That's definitely gone, and that gives me y equals 1/2 times the quantity x minus 4 squared plus 1, which is simply the reflexive of this. Didn't see that one coming, huh? I didn't either. I wasn't sure if it was going to work. I was going to test my theory, though. But it sure worked, and that's the options right there. Yeah?
For number 8,
No, I didn't. Was 8 the word problem? Yeah, I didn't do that one. Now, I want to point out some things real quick. I knew there was going to be about at least 3 of them because this one is in your standard form. This one is written in standard form. That's like the, do you guys remember when you guys did ax squared plus bx plus c? That's the standard form. They went from highest to lowest. See that? Squared, first degree, 0 degree. This one is written in what's called vertex form. That's horrible. That looks like vertex. This is written in vertex form. Vertex form. And this one is your focus-directrix form. Focus/directrix.
Why are there so many different forms?
Because different ones give you different things to look that you can find. Kind of like a Rubik's Cube. That's what makes math so fun. Until Daddy takes a T-bird away. You guys ready to prove some parabolas?
No.
No.
No, but I'll still try.
What if I promise that it's going to be easy?
I still don't think it's gonna be easy.
What? What have I done to break that trust? I've made everything look easy.
No.
Okay, you make it look easy, that doesn't mean that it is easy.
Okay, I'm gonna, yeah, that's true, I'm sorry. Alright. Tell you what, how about I go George Bush and no child gets left behind here?
Okay.
Alright. We are going to write, and I'm going to do this differently because for the other class I used a grid, and they were trying to count. And it's not about counting because what we want to do first is we want to create the equation for the parabola. Okay? And there can be no numbers. Okay? So, and I used the one that had the little lines, and people were like, oh, that's 2 units. And I made a mistake where I went, oh, this is 3, but it really wasn't. So if you see the video, you'll be like, oh, my bad. I was counting 2. So let's start with this. Are we good? Everyone understand that this is simply the x and y axis?
Yep.
I think you've seen enough that you can make the safe assumption, right? Let's start with the vertex here. This vertex has to be centered at 0, 0, doesn't it?
Yeah.
Look at my little owl. Ah, okay.
I've seen it since I think it was fifth grader. Wrote that down the first time. I was like, it looks like a koala. The
big ears,
Yeah.
and the big eyes,
And the weird nose.
the weird nose.
Oh, I see.
That looks like an owl.
I always see an owl, but I see the koala.
Oh,
And then there's his little his little hands holding onto the bamboo shoot. That's horrible.
That's funny.
Yeah, it's funny though.
That's
So-
cute.
I still don't see a koala.
Well, then you can go die.
Well,
Please.
what happened?
Are we giving death? Don't take it seriously. Not today.
Please don't act up on me. All right. This is going to be our, let's see, let me pull this V. This is going to be our focus. That's going to be our focus, okay? The focus, it's just on there, isn't it? It's not a specific point. Fantastic. However, what's beautiful here is we can still label it. And we're going to label it. What's the x coordinate here? 0. And how far up do I have to go to get to that focus?
how do you know?
You don't know, but what do we call that distance? What do we call that distance? We call it P, don't we? Fantastic.
Oh no, sorry.
Okay? Now, since I have that, I also need a directrix. Don't I? I need a directrix. And where's that? What's the equation of this directrix? Not P, negative P. Y equals negative P. Cool? Alright. Now, do you guys remember the one rule about a parabola? Where do its locus have to be? They all have to be equidistant, right? So I'm just going to go ahead and draw some parabola here. And I'm going to pick a point, and I don't know where this is. This is just out here somewhere, isn't it? What are its coordinates? Well, I don't know. I have no way to associate those with P or 0 or anything, do I? So we're just going to call that coordinate x, comma, y. Are there any questions so far?
Why did you put y?
Wait, so you just randomly put a parabola?
Because that's the equation to that. If let's say if P was 2, that's 2 units up, isn't it? Well, to get here, I have to go 2 units down.
Okay.
Cool? Fantastic. Edamame! Everyone okay with everything I've done up here so far?
Yes.
Cool. We're not leaving anybody behind here. Rocky Ride, Toto Tan. Cool. Now, somebody over here said that they have to be equidistant, correct? So that means that the distance from this focus to this point, this random point, has to be the same distance as that point straight to the directrix, correct? Now, we know that by Pythagoras' theorem, good old Pythagoras doesn't fail, we were able to create this thing called a distance formula, weren't we? Okay? So that means that the blue line has to be the same distance as the red line. Right?
It actually looks like it is.
Well, that's a fluke. In my yesterday's drawing, they really weren't. They didn't look a lot alike. So let's see here. I know that the distance formula reads the square root of x sub 1 minus x sub 2 plus y sub 2 minus y sub 1, correct? And actually, let me use, what color did I use for the first line? Blue. So I know that the square root of x sub 1 minus x sub 2 plus y sub 2 minus y sub 1. You guys remember that? X sub 2 minus x sub 1, y sub 2 minus y sub 1. Correct? That's the distance formula?
Yeah.
And from what we just said, one distance has to equal the other distance. So that means that the red line also has to follow this form of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. True? It is the same, but one is the blue line and the other is the red line, correct? And we know that these two must equal each other. That's why I created the equation. Blue line equals the red line. Any questions here? This is saying, doesn't it? The blue line equals the red line.
Yes.
Fantastic. Fishy, are we good? Yeah. All right. Someone said we're not good? Okay, I would love to wait. I want to make sure everybody gets this. Right, Jaeger?
Wait, why did you use that formula?
Because in order to create a parabola, don't all points have to be equidistant? All locus have to be equidistant from focus to directrix?
Yeah, but what did you say?
Well, Pythagorean's theorem, sorry, this formula came from Pythagorean's theorem. Remember that when we did the whole proof on that? It's just using the distance formula. Okay? So, I'm gonna plug these numbers in now. You guys ready?
Yeah.
I'm gonna plug in some numbers. Actually, you know what? I need to label a point first. Do you guys see this point right here?
Yes.
I need a label for it. I need a coordinate for this green point here, where it's gonna make that distance, don't I? That segment. Anybody got ideas?
It's like 6 things, a random number.
Well, they're not random. They're very specific, aren't they?
X, Y.
It's x, y, x.
X,
Because didn't we label this x, y?
yeah.
So shouldn't it have the same x here?
Yeah.
And what's the y value? Not negative y, because that's y up there, isn't it? Negative p. It's on the directrix. So it's negative p. So that has coordinates of x comma negative p. So everything has a coordinate now. Yay! Here we go. Ready? Okay, here I go. Colors are amazing. You guys should get color pencils. Are we ready?
Yeah.
Okay, here we go. First, the difference between the x's. So the difference between the x's, so this is x minus 0. X minus 0. That goes here. X minus 0.
Wait, how did you do it first?
Because that's my second. Remember, it's always the big value minus the small value, isn't it? And since this one's further to the right, it's bigger than closest to the left. Okay? And then let's look at the y's. So plus something squared. Now it would be y minus p. So y minus p. Cool? Well, that was easy. That has to equal the red part. So the square root of, so let's look at the x's here now. So x minus what? Sorry, here's our second x right here. And this is our, because we're finding that distance, aren't we?
Isn't this the same exact thing as that one?
No, it's not. The distances are the same length, but the coordinates are different. See, here we were doing the blue, weren't we? So we have to use this with that. Now we're doing the red piece, so it's this coordinate with this coordinate. So it would be x minus x. So x minus x plus, and what's the next binomial?
Negative p.
Y minus negative p.
Wait, what is that one?
Because that's higher, isn't it? Remember, it's always the big one minus the small one. Since this one's more up, then that means it's got a greater magnitude than the bottom one. Can I say magnitude? No. But you get what I mean. So there's my setup. Okay, you guys ready to continue?
Yeah.
All right, I can hold on. I'll just enjoy a swig of this Java here. Right. At that distance, I'm kind of fine. Because that's how we find distance. Remember we did that with Pythagoras theorem when we proved this? All right. So let's continue. This is kind of sloppy, so I want to clean it up. Is that cool with everybody?
Yeah.
So let's, well, I don't want to say sloppy. It's just really congested. So let's take care of this. X minus 0 is just x, isn't it?
Yeah.
So that's just x squared?
Yes.
So I've got x squared plus, and I don't want to mess with that yet. So y minus p squared, and that equals the square root of, oh, this is cool. X minus x is 0, isn't it? And 0 squared is still just 0. Now in here, though, that gives me y plus p, doesn't it? Because negative negative makes a
Positive.
positive. So that's kind of cleaned up nicely. You okay? Someone need to swallow their heart again? There's a bunch of owls? What bird makes that sound?
It's the one they're out front of my house. I think it's the pigeons.
Yeah, the pigeons do. You're right, the pigeons do.
They're like, still in front of my house. They're always in front of my house.
Okay.
You act like you have birds outside of my house.
Those are my birds! They're on my property. I don't know about you guys, but I don't like those square roots. So let's get rid of them, cool? I know that I can get rid of it if I square this side, correct? And if I square that side, what do I got to do to the other side?
Square it.
I've got to square it. So let's square those. Oh, well, that's nice. They just kind of gone, aren't they? And I'm left with what's inside, which is x squared plus I think I'm ready to expand that now.
What?
I think, yeah, there's no avoiding it now, is there? I mean, it's kind of there already. So I'm going to expand that y minus p squared, okay? I mean, there's no avoiding it at this point.
What did we
Wait,
do?
so what did the square root do to the problem? Or is it just stays the same?
It got rid of the square roots.
Oh, okay.
I got rid of, see how I put lines through those? So here's what I've got. You guys ready?
Kind of.
To square this, it's going to become y squared minus 2 py plus p squared equals. It's just binomial expansion.
I was so close.
I was foiling it. Okay?
Why is it foiled?
I don't know. The proper term is binomial expansion.
Actually, I'll start calling it.
So I'm gonna use the proper terminology. Yeah. Because it's a perfect square. So when I take eventually when I go y times negative p, it happens twice. And I can show you in a little bit, okay? Actually, do you want me to show it to you now? Y minus p times y minus p. Y times y is y squared. Y times negative p will give me negative yp. And then this will give me negative yp. See how it happens twice? And then I get positive p squared. So that's why it's two of those. So as I go over here, and I do the right side, same idea. I'm going to get y squared. This time it's positive, so it'd be plus 2 py plus p squared.
Where'd that p come from? P squared, the last one.
Negative p times negative p.
But isn't that with the 2py?
No, here, let me show you here. If I go this times this, I get this one. And this is the negative 2py. Cool? Okay. What happens? I heard someone talk about canceling out. That's a good eye. What cancels out?
Negative 2p.
The y squares cancel out, don't they?
And the negative 2py.
No, that's a positive. That's a negative. They can't cancel. But the p squares do, don't they? So here's what I've got. Clean this up. S squared minus 2py equals 2py.
Hold that thought.
Too late. Let's move that 2py that way. So I'm going to add 2py here and add 2py here. Wait for it. X squared equals, 2py's and 2py. How many py's do I have? If I have 2py's and I add 2py's, I've got 4py. Ah, yeah! There it is! Math!
This class is too much for me sometimes.
All that work for that.
Math! Because if I let's say I just went minus y squared and minus y squared, 0, 0. You are so beautiful.
I'm gonna go now.
And I never sold it. It was always for donation.
But people were like, "Should I take it?"
They were. And then I was ending spending more money than I needed to. Because technically the idea was I bought water one time and then it would replenish itself. Because you guys would kind of at least donate the minimum cost of 10 cents. And it wasn't happening. Alright. There's your proof, peeps. Yeah, some people will put in more, but some people would just take 3 bottles and not put anything in. So that's your bottles extra and then some. When I had the pieces of water. Vending machine? Huh? Man! Isn't that cool? I'm sorry, I'm just coming down still.
Wait, Miss Junior's go back up.
Like, this is as loud as I shut up. I don't get I do.
What's edamame?
Edamame.
What's edamame? There's no accent on the E.
It's edamame. You know what it is.
I don't know what it is.
How'd you read it?
But I don't know what it is. Just because I read it doesn't mean I know what it is. You know what fracking is?
What? I've heard of it. Oh yeah! Kind of. I was watching the thing. Well, you see, it's a focus-directrix.
Okay, so are we good? I just realized. Thank you. That even though I did the proof, it really doesn't help you with number 8. I thought it might have cleaned stuff up, but here's what I know. So let me give you a hint at least, okay? So I'm going to give you a hint here. I know that this is a vertical parabola, so it has to follow the form of x squared equals 4py, correct?
Yes.
And I know that this distance is 4.
Yep.
Yeah.
So that means that it's x squared equals 16y.
Yeah.
And I also know that if I plug in an x or a y, it spits out the other, doesn't it? So if I plug in an x, it spits out a y. If I plug in a y, it spits out the x. And there's your clues.
So we plug in 0 and 4.
It's a function machine. If I put in an x value, what's the only thing left behind? So I would solve for a y. If I plug in a y, what's it going to produce? Plug in a specific value for a coordinate. You're trying to get this distance, aren't you? So what you want to do is get these coordinates. So let me ask you this. What are the coordinates to this point right here? No. If this is question mark, comma, 1, 2, 3, 4. And this is question mark, comma, 4. So, wait a minute. I know the y value, don't I? I just said to answering this whole thing. I know the y value. The y value is 4. So if I plug in 4 for my y value, 16 times 4, I'm going to get x squared equals, what is that, 64? And if I square root both sides, that means that x is plus or minus 8. So that means that x is a positive 8 and a negative 8. So the coordinate here, this is a negative 8, and this is the positive 8. And now I can find the distance between them, which happens to be 16.
Oh yeah, because you add them.
Thanks.
Who asked this one?
Everybody.
I ended up answering the question I didn't want to answer.
Well, there's plenty more, I'm sure.
That's the problem with giving like little tips. It's like, you're already there, right? Might as well finish it.
But at least we get it. Like, we understand. I understand it easier when you explain it.
That was good, huh? That's like the iPhone one. It's just Logan.
Go ahead, Rick. Finish up what you got. And if you did it already, then you're good to go. What's up? Yes, definitely. Yoda? 7? NASA. Nah, I already did one. I'm not doing it anymore. Try it this weekend. And then we'll answer them on Monday. Let me end this. 'Cause